All right, so the forces on this negative 3q would be a repelling force up due to the 4q, an attractive force down and to the left due to the plus q, and a repelling force to the right from the negative 2q. Okay, so we've drawn a free body diagram. What's the next step? What's the next step, Navina? Sum the forces. Okay, so let's sum up those forces. Summing the forces in the x direction. Okay, so when we sum up the forces in the x direction, F2 is positive, F1 has that negative component, cosine 45, because it's a square that's a 45-degree angle right there. So now let's sum the forces in the y direction. All right, so we sum up the forces in the y direction. F4 is positive, and then the y component of F1 was F1 sine 45. Now we need to find what is F2, what is F1, and what is F4. So F4 was the first one, and we have an equation for that, right? The force between two charges. Dylan, what's the equation for the force between two charges? Yep. Okay. All right, perfect. So would that be like 12kq squared over d squared? All right. Now let's do F2. That would be k absolute value of 3q times the absolute value of 2q all over d squared. Remember, it's a square, so all the sides have the same length. So that would be what, 6kq squared over d squared? Now what about the q in the bottom left-hand corner and negative 3q up here in the right-hand corner? What's their distance of separation? Do you remember how to find that diagonal length for a square? Use Pythagorean theorem, that's right. And I just drew your name. And so what would it be? So r for the diagonal would be the square root of what? D squared plus d squared? Which would be the square root of 2d squared? Which looks like d root 2. Do you remember from geometry, side root 2 for a 45-45 right triangle? Isn't that what we have here with a half of this square? Okay, so then F1 would be K Q Q over, now your R is D root 2, side root 2, but it's all squared. Squared. Okay? So what would that be? 3kq squared over 2d squared? Okay, so at this point, since you have D and you have Q, could you solve for F4, F2, and F1? All right. Could you then substitute it back in up here and find your sum of the forces in the x direction and the y direction? All right, so I'll leave that as an exercise for the student. That was my favorite thing for my professors to say. I'm being facetious. But when you sum the forces in the x direction, you should get, and most of you did this Friday, and it was pretty good, 2.35 newtons. And when we sum the forces in the y direction, I got 5.2 newtons. So use Pythagorean theorem to find that force. Now what about the angle? Antoine, how do we find an angle? We have an x component and a y component. Uh-huh. So then theta would be the inverse tan?